Whenever. Go. Did you start it? Okay.
So today we're going to evaluate the definite integral, and it's a no calculator problem, so this would be really easy if we could just plug this into the calculator, but since it's no calculator, you're going to have to use the fundamental theorem of calculus, which states that the integral of f of x is equal to the integral f of b minus f of a. So the first thing that we need to do, according to this, is to find f of x, because right now all we have is our little f of x. So we need to find the integral, and this is what we have. So right here you see this is the f of x we have, and you can't, there's no chain rule for integrals. So sometimes people will accidentally take the derivative because there's a chain rule for derivative, but since it's an integral, there's no chain rule. So you have to use something called U substitution. And in U substitution, you usually substitute something for u. So I'll show you how to do this. So I like to do is put my dx by my x squared, because what you're doing is your u is what's inside the parentheses. So this is how I write it out. So this right here, that's your u. So u is equal to x cubed plus 8. So you're going to find the derivative of u, du, which equals 3x squared dx. Now you want your dx, your derivative of your u, to be equal to the dx in your equation, which in this case is x squared dx, and down here you have 3x squared dx. So all you have to do is divide each side by 3, and that's how you even out your equation. So now you move on to what you find is f of u. So it's going to be f of u equals 1/3 u cubed 1/3 du. Now we can plug in, and what I did here, as you can see, I just did your integral rules for u. So what normally you'd have is u squared. You just add 1, which you get 3, and then divide it, your coefficient, by 3. So it's 1/3 u cubed. And then you multiply it by your du, which in this case is 1/3 du. So what you're going to do is substitute your u, and your du goes away, but you keep your constant. So f of x is equal to 1/3 x cubed plus 8 cubed, or I'm sorry, 1/9, because you multiply 1/3 times 1/3 to get 1/9. So now that you have your f of x, you're going to find your f of b and your f of a, so you can use the fundamental theorem of calculus. Now, that's pretty simple. All you really have to do is just plug in your numbers. So b is 1 and a is 0. So f of 1 and f of 0 And this is just basic algebra. So, I mean, everyone kind of knows how to do this at this point. So, you take your equation, 1/9, 1 cubed plus 8 cubed. And this comes out to 1/9 times 9 cubed. And I'm going to leave it in a fraction, and you'll see later on why we do that. Over 9. And this one's going to be 1/9 0 cubed plus 8 cubed, which becomes 1/9 8 cubed 512 over 9. So now it comes down to the very end. This is a simple step. Now make sure that you're doing f of b minus f of a and not the other way around, because that will give you a completely different answer. So your f of b is 729 over 9 minus 512 over 9, which equals 217 over 9. And this is, it doesn't simplify anymore. It's an exact value, so you're just going to leave it like that as your answer. And this is equal to the integral 0 to 1 x squared. And this is like a proper way to write it. So that's what you would do, and it's pretty simple. And just some things to remember is make sure that when you're finding the u value to substitute, that it's in the parentheses and it's not x squared. So that's not, and that's pretty easy to find out because it's going to be much more difficult if you use x squared as your u, and things aren't really going to work out and you'll go to the top and realize what you did. So, but if you can get it right the first time, it'll make it much simpler. So in these equations, you just find